What's going on, everybody? Today we're going to be doing another LeetCode problem. This one is called longest consecutive sequence. It's a medium, and I'll be answering it in C++. So let's get into the problem statement. So we're given an unsorted array of integers called nums, and they want us to return the length of the longest consecutive element sequence. Now, what is the longest consecutive element sequence? In the context of this problem is basically just the length of the longest sequence of increasing integers. So for this array, we can see that the output is 4, and that's because the longest sequence of increasing integers are 1, 2, 3, and 4, and that has a length 4. Likewise, for this example, we have 10 elements here. Notice we can have repeating elements. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in this set, but the sequence length is only 9 because we're going to ignore one of those zeros and just have 0, 1, 2, 3, 4, all the way to 8. So they want us to write an algorithm that runs in O of n time. So for the naive approach for this problem, you could imagine a simple way to solve this would just be to sort the array and then just use some kind of algorithm to check what the longest consecutive sequence is from that sorted array. Now the problem with that is the time complexity is going to be at best in log n, because sorting algorithms that are built into programming languages are generally in log n time, where n is the size of the array that you're sorting. So this isn't good because that's going to be, it's going to have a worse time complexity than their desired linear time complexity. So for the optimal approach, we're actually going to want to use we're going to want to convert the array to a set. And using the set, we can eliminate duplicate numbers, and we can have constant lookup time to search for sequences. So our time complexity for that approach is going to be linear, big O of n. So for this approach, we're going to want an unordered set of integers, and I'm just going to call this set. And then to convert the input vector nums to a set, we can simply iterate over nums. So for int num in nums, we just do set dot insert num to put that number into the set. So that is basically all the code for converting our vector into a set. So now that we have that, we can get into the algorithm. We're going to leverage the set data structure to write our algorithm. Now we need an integer to store the longest sequence, and notice that the array can be as small as 0. So for our longest sequence, we do need that to be initialized as 0 in the event that the length of the input array is 0. So longest is going to be 0, and the first thing we're going to do is basically we're going to look for the start of a sequence in the set. Now, how do we know which elements are the start of a sequence? Well, if the preceding element doesn't exist in the set, then we know that that element is either, by itself or the start of a sequence. So, and that's really what we're looking for. So we can do for int, we'll call it start, since we're looking for the start of a sequence. For int start in our set, basically we want to check if it is indeed the start before we start looking for the next elements. So if set dot contains start minus 1, and we actually want to see if the set doesn't contain that previous element. So if it doesn't, then we know that that's the start of a sequence, and we can start looking for the next elements. So the current end is going to be equal to, so we'll say int n is going to be equal to the start of the set plus 1. And then what we want to do is basically loop while the set contains the end element. And while the set contains the end element, we can increase the end element. So that's basically going to keep extending the streak so long as it exists in the set. And once we're done with that, once the set no longer contains the end, we know we've found the end of the streak. And the way this works, if there is no increasing elements, is the length of this current streak will just be 1, since we're gonna update longest to be the max of the current longest value, and then the current streak, which will compute by doing end minus start. So if end doesn't really exist, we'll get a streak length of 1, so that's fine. So this is pretty much the code. I mean, isn't much more to this algorithm. So we want to return longest, and I'll just look through this briefly to see if there are any bugs. Doesn't appear so. So I'm just gonna go ahead and run this. Now there's a couple optimizations we can make. We can actually have this num as a const reference to avoid reallocating space. So the reference is to avoid reallocating space, and then the const is to avoid altering the original element accidentally. So we can do the same for the start for a minor performance increase. So yeah, just some minor optimizations. Again, the time is going to be linear, and the space is going to be, the space is also going to be linear. Well, say big O of n, because we need a set. We're using a set data structure, and that's going to correspond, exactly to the size of the input vector. And then the time is linear once again because converting the set or converting the vector to a set is takes linear time for each element, and then this part of the code is going to be linear time in the worst case, because we're not even checking every element necessarily here. Well, we are checking every element, but we're not going to go over a streak more than once, just by the nature of this code. We're only looking for the start of streaks, and then that's where we begin checking them. So we'll just submit this so we can see the percentages. But yeah, I hope this helped you understand this problem. If it did, please leave a like and subscribe for more of these videos, and I will see you guys in the next one.